All right, welcome back, nerds. This time we're going to do. I'm going to show you the law of cosines and do one little example here to help you get through the Khan Academy. Okay, so the law of cosines is again an interesting and kind of even more ancient thing in trigonometry. It actually goes back in an early version all the way back to Euclid in the third something century BC. So people have been using this for a long, long time. And as you'll see, it's actually kind of a more general way of expressing the Pythagorean theorem. And I'll talk about that a little more in a second here. Okay, so the law of cosines, sometimes you'll see it as the cosine rule. Okay, maybe a little less intuitive than the law of sines, but I don't know. If you're given any triangle, again, same idea as before. So I have, say, any triangle like this with angles A, B, and C, and sides little b, and little c. All right. The law of cosines tells us that c squared. Sorry, that's little c. I should make that a little bit littler just so to emphasize that. Let's see, little c, the side length c squared equals little a squared plus little b squared minus 2ab cosine of c. Okay? That seems like a little bit of a lot, but you'll notice, again, there's some deep similarities here to the Pythagorean theorem. And again, I'll explain in a minute that this is actually just kind of a more general way of expressing the Pythagorean theorem that extends it to any triangle. Okay, so that's the law of cosines right there. Again, you might probably want to make sure you write that down while you're working on these. But that's what we're going to be using for all this. Okay, so I'll give you a second, and then let's do an example here, show you how this works. All this stuff, again, when you see the law of sines, law of cosines, all of it, it's just kind of using the formula, plugging in some stuff, and solving it. There's nothing too crazy complicated about it. If you can use a calculator and square things and add stuff and subtract it, you can do all this. Okay? So, again, say we're given a triangle here. Draw this up in the corner. And again, this works for any triangle, regardless of whether it is a right triangle or not. Again, we'll call these angle A, angle B, angle C. Say we're given two sides and an angle, and we want to find a third side. Okay, 11, 8, and then we'll say this angle is 37 degrees. Again, this is just an example. And this side, little c. We want to figure out what that side is. Okay, so again, do not assume that this is a right triangle. Doesn't have to be a right triangle. That's the nice thing about this law of sines and law of cosine stuff. Okay, so basically, I just have to kind of plug this in and figure out what's what, and then just work it out. So here, across from angle A is going to be side little a. That's the 8. Okay. And then across from angle B is this side little b. That's the 11. All right. And then we want to find this side little c. Okay. All right. So we're going to set this up like so. C squared, it's little c, again, side, which is what we're actually trying to figure out, equals a squared, which is 8 squared, plus b squared, which is 11 squared, minus 2 times little a, which is 8, times 11, which is side little b, times the cosine of 37. Okay, so again, the angle that we're going to plug in for the cosine here is always going to be the one opposite the side that we're interested in. Okay, although obviously you can replace other parts of this and use it in a little bit more general way. Okay, but so now everything is set up, and now we just kind of have to work it out. Okay, so again, this is c squared equals 64 plus 11 squared is 121. 2 times 8 times 11 is 176. So minus 176 times the cosine of 37. Cosine of 37 is about 0.798. Okay? So again, all I did was just square that, and multiply 2 times 8 times 11. That gives me 176. And then the cosine of 37, I just use a calculator, it's 0.798. Okay, make that clear. That's an 8. All right, then I do 64 plus 121 minus 176 times 0.798, and you should get about 44.44 or so. And keep in mind that is equal to c squared. Okay, so to get c, the side that I'm interested in, I just simply take the square root of both sides. Square root of 4.44. Take the square root of that, and that is equal to about 6.67. Or in Khan Academy, that would be 6.7. Okay? I'll make it just like that. 6.7. There you go. All right, that's it. What's kind of interesting is, again, I'll show you this. This is really just a neat thing about this. Kind of a total math nerd deal. But what's kind of cool here, let's write down this c squared equals a squared plus b squared minus 2ab cosine of c. Okay. What's kind of neat is if you think about a right triangle, okay, where this angle c is 90 degrees. All right, so the side little c and these other sides a and b, if we call this angle big C, okay, if you remember from doing the unit circle trig, the cosine of 90 degrees is 0. Okay, so what this really is when this angle C is 90 degrees, if I plug in this whole thing, if cosine of C is equal to 0, that means this whole part back here gets canceled out because it's minus 2ab times 0. 2ab times 0 is 0. So the whole thing reduces to c squared equals a squared plus b squared, which you damn well better know is the Pythagorean theorem. So again, it's kind of neat to think that the Pythagorean theorem is really just a special case of the law of cosines. All right. That hopefully should, between this and the law of sine stuff, I mean, don't forget all the stuff about inverse trig, plugging in. I mean, you might have to solve for different variables in there, but I think you guys can handle that for the most part. Okay, use the hints that they give you and watch the videos on Khan Academy. But I'd like to see you try and get through this mostly on your own. But that's pretty much everything you need to know there. Okay. All right. That's it. Have fun.